In the last video, we saw how to use frame count and mod to create a pattern of repeating numbers. Those numbers could be used to create repeating patterns, and those patterns in turn can be used to control anything that's changing on the screen over time. There are an infinite number of repeating patterns that you can design. Instead of trying to cover the whole field, here I'm just going to give you 5 basic building blocks that you can use to derive your own patterns. These are the 5 patterns. Each of these green boxes contains one instance of the pattern, and the instance just repeats over and over and over in time. Let's look at each of these patterns in action, and then I'll give you the recipe in processing for producing them. Here's the Sawtooth pattern that we saw in the first video. Notice that the pattern starts at 0, works its way up to a maximum value of 1, and then immediately drops right back down to 0. We have a second set of visualizations where I'm blending color, position along a Bezier curve, and the size and orientation of a word. And again, you can see the same behavior. It goes from one extreme to the other and then jumps right back to the start. Let's look at another pattern. We call this pattern a square wave, and you can see from the animations as well as from the wave up top what's happening. First, every animation has a value 0, then 1, then 0, then 1, then 0, then 1 in perfect alternation forever. The other visualizations have the same effect. In particular, look at the color in the upper left. We go from beige to green to beige to green in perfect alternation with no values in between. This is actually useful sometimes. Let's take a look at another graph. In this pattern, we have a random series of numbers that are repeated over and over. So I have a random chunk, and then I just repeat that random chunk. If you look at the graph up top, you can probably pick out the repeats. You can see features that get repeated over and over. If you look at the motion, it may or may not be obvious that that's what's going on. Let's look at the other visualizations, and we can see that everything is moving and it's getting its value from this random series of numbers, and so it's jumping around erratically, but it's still repeating over time. If we want to get a smoother motion, here's one nice way to go. This is called the triangle wave. You can notice what's happening in all of the animations. We go from one extreme to the other, and then we come back, and it's nice and continuous. In particular, look at the pendulum in the upper right. It swings to the left, hits the wall, to the right, hits the wall, swings to the left, back and forth. Each time it hits the wall, it just turns around and goes in the other direction. Let's take a look at the other visualizations. And sure enough, we can see, for example, the little circle in the bottom left swinging from the one end of the Bezier curve to the other and then back again. This is really a very nice way of controlling motion, but it does have one little problem. Let's go back to the previous set and look at the pendulum in the upper right. Notice when it hits the wall, it turns around instantly. It doesn't slow down as it approaches the top of the arc, and it doesn't pick up speed at the bottom. It's always moving at exactly the same speed. A more realistic kind of a pendulum would slow down at the top of the arc and then pick up speed as it went towards the bottom. We can get this kind of behavior by using something called a sine wave. The name comes from its mathematical heritage, which we're not going to get into. But take a look at the wave at the top. It looks like the triangle, but it's been smoothed out, and that's the key thing. Take a look at the pendulum in the upper right. Notice that it is slowing down when it reaches the left and right sides of the box. It's a little bit subtle, so let me slow things down a little bit. And so here things are going much more slowly, and you can see that the pendulum is in fact coming to a halt. If I go back to the triangle, watch the pendulum, it just hits the wall and turns right around and comes back. But when we're using the sine wave, it goes up, slows down, comes to a momentary rest, comes down, picks up speed, and in fact, all of the animations are moving in this nicely smoothed out way. Let's go ahead and put a few more cycles in there and look at the other animations as well. So these are our 5 basic building blocks. I'll now give you the code for each one. We need some notion of time. So just like in the last video, I'm going to save the value of frame count in a floating point variable t. Because t is a float, it means I can do all the operations I want to it, plus, minus, times, divide, and the results will still be a float. We'll still have a fractional part, which we'll see is important. Let's recap by looking at the sawtooth. Here in the green box, you can see one cycle. This is also sometimes called a period. I've arbitrarily decided to give the width of this the value W. It's very important to note that W is also a float, because later we'll divide by this value, and we want the result of that division to be a float as well. So W tells us how many seconds long this wave takes to go from 0 to 1 before it drops back down to 0 and repeats. The recipe we saw in the last video. It's just T mod W divided by W. And because T is a float, we know we can get back a fractional value here. And indeed, we get back a value of V that starts at 0 and then smoothly makes its way up to 1 and then drops right back down to 0 and makes its way up to 1 again. The square wave is maybe a little bit more interesting because it doesn't have to be exactly square. Here I've offset it a little bit so that the time when the wave is high is a little bit wider than the time it's low. That means that our animation will spend a little bit more time in the 1 state than the 0 state. It's not necessary, but it's a nice little variation. So how are we going to represent this? I'll say the time that we're up in the 1 state is U, and the time of the entire wave is W. So as time marches on, we get a value of 1 for U seconds, and then it drops down to 0. And when a total of W seconds have elapsed, we repeat. We go back up to 1, and around we go, up at 1, down to 0, up to 1, down to 0. The recipe for this is just a little bit more complicated than before. We use a conditional. Remember that conditionals are basically little if-then statements that happen on a single line. So here what I'm saying is, if the value of T mod W is less than the value of U, then we return a value of 1, otherwise a value of 0. That's what that question mark and colon are doing. They are creating an if-then. So once again, we read this left to right. If T mod W is less than U, then we return a 1, which means we're at the top of the wave, otherwise a 0. And so V will have the value 1, then 0, then 1, then 0. That takes care of the sawtooth and square waves. In part 2, we'll look at some more sequences.